So hello everyone, and I do hope everyone is well. And I want to pick up on chapter 7 here with preferred stock valuation, which I previously mentioned. Preferred stock valuation is a kind of like a hybrid between common stock and bonds, because there is a fixed dividend, kind of like you would get with a bond. Okay, but you can buy and sell shares as you can do with stocks. So you can see it's got a fixed annual dividend, as I said, and it never matures. Okay, it can be used to find the value of preferred stock. Okay, we can use equation 7.2 here. All right, so if we use equation 7.2, so the value of preferred stock can be estimated by inserting the dividend on the preferred stock and the required return for the preferred stock in equation 7.2. Let's look at equation 7.2. So here's equation 7.2, right? It's this simple right here. Simple arithmetic, right? Division. So a preferred stock paying a $5 annual dividend and having a required return of 13% would have a value of $38.46 if you just do the math. So now we move on to the next type of dividend growth model. We did the zero growth model. So now we look at the constant growth model, where the assumption is made that dividends will grow at a constant rate. Okay, they'll grow at a constant rate. Okay, so it grows at a constant rate, but it has to be less than the required return, and we'll find out why soon. So this assumption that the constant dividend growth rate, it's less than the required return, it's a necessary mathematical condition for deriving this model. Okay, and you'll see why in a minute. So a lot of companies, and if you own stock, you'll notice that a lot of them don't change their dividend much, or they'll have a dividend that will change every year, but at a constant rate. Some companies don't pay dividends at all, as you know, like Google, right? They reinvest into the company for R&D, let's say, okay, or to just run the company. So here's our general model that we talked about. So here's the price of the stock, and so here is a D0. What happened? I'm trying to highlight that, and let's see if I can get that highlighted. Okay. So a D0 is the most recent dividend, okay? Here's the most recent dividend. Now what's important is, you'll notice here as it adds all these up, we're going to simplify this equation here, okay? And we're going to let the next period dividend, and this is very, very important. This is the next period dividend. Okay, and it's going to be written just like it's shown here. Okay, you notice how they're writing this. Okay. So anyway, so they write this. So it comes out that this price, and if you simplify this through some mathematical jockeying, so this is great. The price of a share using the constant dividend growth model simply comes out to this nice simple equation here. And another name for this constant dividend growth model is the Gordon growth model. Okay, so just so everyone knows that, so that's important, you know, historically. So it has two names, so you don't get confused. So all we do is we put the next, and this is important, the next period's dividend here. Here's the interest rate, and we, you know, your required return, and we subtract the growth rate. So here's a nice example of dividends per share, and growing at a constant growth, okay? Constant growth model, okay? So here's a nice example that shows basically they're looking at, from the numbers we see up here, the historical average annual growth rate of dividends. And we're going to look at that as an accurate. Now, again, remember, it's historical and it's average. These are the two key words here, okay? From the past. That it's an accurate estimate of the future, and here's now we go back to the future annual dividend growth rate. To find the historical average annual growth rate of dividends, basically we're going to solve this equation, and now we're doing compound growth rate here. We're using the compound average annual growth rate, and we're going to solve for G. Okay? And we solve for G in this manner here. And if anyone is not clear about this, please email me. This could be a little confusing. And we solve for G, and it's roughly approximately 7%. And we can also use a financial calculator or Microsoft Excel to solve for that. But once we have this number here, approximate number, as we all see, you can plug that into here. And here is the price of a share of this stock. And it comes out to $18.75 a share, okay, with the numbers we have. Because here's the dividend, okay, for one period, right? That's 1 plus G, right? 1.07. So your required return is 15%. The 2020 dividend, we know the 2020 dividend, it's given to us here, $1.50. Everyone sees that, right? $1.50. And that's about 7% more than the 2019 dividend, right? And we get $18.75 a share. And here is the growth rate, right? Somewhere there's a growth rate here, right? Or your required return. Here's your required return, right? So we got that. We pop that in. So we got all the information we now need. Okay. And you could use a calculator. Okay. All right, so let's look at this nice example here.
In many instances, financial analysts want present value perpetuity stream of cash flows that grow over time. An important step in this valuation process is to estimate the rate at which cash flows will grow. Often the simplest way to estimate the constant growth rate, G, is to calculate the rate at which the cash flows have grown in recent years. In this example, we have a series of dividend payments made by the Lamar Company starting in 2014 and going through 2019. By comparing the dividend paid in 2014 to the one paid in 2019, we can calculate the average compound annual growth rate in Lamar's dividends over this period. Just express the 2019 dividend as the product of the 2014 dividend times 1 plus the growth rate raised to the fifth power. The 2019 dividend is $1.40. That must equal the 2014 dividend of $1 times 1 plus the growth rate raised to the fifth power. All that remains is to solve for G. Algebraically, G can be isolated by first dividing both sides of the equation by the 2014 dividend of $1, then raising both sides of the equation to the 1/5 power, and finally subtracting 1 from both sides of the equation. Solving the left-hand side of the equation, G is found to equal 0.0696, or approximately 7%. Thus, the growth rate in Lamar's dividends is about 7% per year. Once we have an estimate for the growth rate in dividends, we use the formula for a constant growth perpetuity to determine the value of Lamar's stock. If the dividend in 2019 was $1.40, and we expect dividends to grow by 7% per year, then the 2020 dividend will be about $1.50. The formula for the present value of a growing perpetuity says that the value of the dividend stream equals next year's dividend, in this case $1.50, divided by the difference between the required rate of return on the stock and the growth rate of dividends. So if the required rate of return is 15%, divide $1.50 by 15% minus 7% to find that the value of Lamar's common stock is $18.75 per share.
So that was a good example of what we went through already. So it's good to check the textbook examples. Okay. So it's a quick, easy example. Okay. All right. Now we can get into more complexities. We can get more complex with this. And there's a variable growth rate model, which basically shows us how dividends will grow at a variable growth model. And what I'm going to do is I don't want to hold you responsible for the variable growth model because the mathematics gets very complicated here. You can see this. I just want to show you there's several steps to get the variable growth model. So this was not something you've got to worry about. Okay, so just want to make that clear to everyone. You could read it on your own if you'd like, but it's several steps long and it gets very cumbersome. So they have an example here though of the variable growth model, and you can go through this with each step if you'd like. It's a good example to go through, but again, you're not responsible for that. Okay. Now the question often arises as to what happens if you don't have a stock that pays dividends. A lot of stocks don't pay dividends. How do you get the price of the stock, right? So as an alternative to the dividend valuation model, we have something that uses the free cash flows from the financial statements that the company has, okay? And we try to get the value of the stock from the free cash flow valuation model, it's called. So this is a model that determines the value of an entire company as the present value of its expected free cash flows discounted at the firm's weighted average cost of capital, which is its expected average future cost of funds over the long run. Okay? So we'll use those numbers. And it's based on the same premise as the dividend model, except we basically replace the dividends, because there are none, with the current future cash flows. And the present value of the share of a common stock will be the present value of the cash flows. All right. So we're gonna value the expected free cash flows, and we have to look at Chapter 4 here. And it's going to shoot me back to Chapter 4, but I don't want to do that, okay? So this is so you can go look at review Chapter 4, and basically free cash flow. The very definition of free cash flow is the amount of cash flow available to investors, okay, who are the providers of debt and equity. That's the investors, right? After the firm meets all its other obligations. So that's what's ever free, okay? Available to give to the debt and equity holders. So we're gonna use a very similar equation as we saw. The only thing we're going to replace, here's where we replace the dividends with the free cash flow, right? And I'll highlight this in pink, all right? So here's the free cash flow instead of dividends, and here's the company's weighted average cost of capital. So you can see the model is very similar to what we had. So here's the weighted average cost of capital. So you can see the similarity, all right? So It only gets, so this is the value of the entire company, okay? So what we're going to do is we're going to stop here now, and I'll pick up, because it gets a little more complicated in the next video, okay? So what we're going to value here, as you see, is the value of the company, but then we got to do a little more logistics mathematically to get the share of stock, okay? Because this includes the debt and the stocks, okay?